All right, welcome back. This is video 5 of section 6.2, the definite integral. We're going to talk about two things in this video. And the first is, well, what do I do if my area is below the x-axis? We have to do some little workarounds. And then secondly, we're going to explore some transformations of functions and see what that does to the integral. So let's start with an area below the x-axis. Remember, we've talked about the integral as the sum of all these little things. And here's the problem that we run into. Well, change in x, well, that's a constant for my function, so I don't have to worry too much about that. But if I look down here, f of x sub I, the value that I am using as the height of this rectangle, is less than 0. So if I take the integral of this little bit, I'm going to get a negative number. Clearly, the area, if I'm just interested in the area, is going to be a positive number. So what we do, and it doesn't really matter that much, doesn't come up that much, but I just want you to be aware of it, is that if I want to find the area of a curve versus the integral, I have to take the negative of the integral if the function is less than 0. Now, remember, the integral will be negative. The integral is less than 0, but the area will be greater than 0. All right, won't come into play very often because usually we're not talking about area, we're talking about integrals. Now let's dive into a little bit of an exploration about some integrals. And the integral that we're going to start with is the integral from 0 to pi of sine of x dx. We'll draw a little sketch here. What does this look like? Well, we all know that sine from 0 to pi looks like that. It maxes out at 1. And I am going to tell you right now that that has an area of 2. The integral from 0 to pi of sine of x dx is equal to 2. I'm not going to prove that to you. I'm just going to ask you to accept it. So, what happens if we move around? What happens if we transform this sine of x function? So first of all, let's look at the integral from pi to 2 pi. Well, we know that that's this chunk of the graph, and that we're talking about this area down here, and therefore this must be equal to negative 2. It's the exact same size, but it's on the bottom instead of on the top. All right, let's take a look at, well, let's combine them. Let's go from 0 to 2 pi of sine of x dx. Well, again, we're now looking at this. We know that this is 2. We know that this is negative 2, and therefore the integral of the combination must be 0. Okay, let's look at, how about this? Let's just take half of it, 0 to pi over 2. This will be a little uninteresting because whatever, but hey, let's do it anyway. Here we go. Here's 0 to pi. We know that this is 2, and we only want to look at half. And since sine has symmetry in each of its waves, we know that that must be half of 2, which is 1. All right, next, what are we going to look at? Let's look at 0 to pi of 2 plus sine of x dx. Well, let's think about transformations of functions. This is a vertical shift. So I can look at this graph of sine, and if I'm shifting the whole thing up 2, that means instead of starting at 0, it is going to start at 2. It's going to end at 3. It's still going to pi. It's going to go like that. Well, I know that this area is still 2, but this area is just 2 pi. So this is equal to 2 pi for the vertical shift portion plus 2 for my original function. Okay, let's see, what else have we got? We got a couple more here. Let's do the integral from 0 to pi. Let's do another transformation. 2 sine of x dx. Well, if my original graph was this, my new graph is going to be twice as tall. So this is maxing out at 2. Well, think what's happening to each of my rectangles. Every single one of my original rectangles is now twice as tall. So if the area of this was 2, the area of the whole thing would have to be 4, because I'm just doubling all my rectangles. Okay, let's see. How about the integral from 2 to pi plus 2 of sine of x minus 2 dx? So what do we have here? We have a horizontal shift. We're moving it 2 to the right. But here's the thing. We also moved our indices 2 to the right. We started at 0 to pi, and we just said, let's go to 2 to pi plus 2, so nothing changed. And finally, let's look at cosine, 0 to pi of cosine of x dx. And knowing that sine is equal to 2, and knowing that cosine looks like this, and it's the exact same shape as sine, we could say, well, that's going to be 1 and this is going to be -1 because that whole curve is 2, but we just shifted it over by a half, which means that the integral from 0 to pi of cosine x dx is just going to be 0. Okay, basic introduction. We're going to be diving more into these ideas of some of these rules of integrals as we go further. For now, we'll go ahead and stop right here. Thanks for watching.